Hi, this is Jeremy Jansen, and today I'm going to be bringing you the December 2009 issue of Reason Wizardry. This is our last issue for the year, and as our first year of Wizardry comes to a close, I'd just like to thank everyone for sticking with it and giving me great feedback on each issue. I'm going to try to make Wizardry even better in 2010. And I can't do it without you, so please continue to email me or post on our forum or the Propellerheads user forum letting us know what you'd like to see. Alright, before I get started with this issue, I'd like to remind everyone about the upcoming deadline for the Wizardry patch contest. Make sure to get your patches in by January 10th, 2010. And if you have questions about the contest, be sure to contact me sooner rather than later. For this month, we're going to be talking about a very underrated and underused Reason device, the BV512 Vocoder. We all know that the Vocoder is useful for robot voices and for, classic Pink Floyd sounds, but the BV512 is also really useful for some sound design that you probably haven't considered yet. So that's what I'm going to go through with you this month. So before we start talking about the BV512 and sound design applications, I first need to just talk about what the BV512 is. So you already know that it's a vocoder, but how does that technically work? It's actually a series of bandpass filters. So essentially, when you run something through the BV512, you're splitting up the signal into a number of different bands. So you can split it up into 4 frequency bands, 8, 16, 32, and 512. The 512 mode works a little bit differently, the math behind it, that is. I'm not going to get into that. One of the main considerations to remember is that the 512 mode actually introduces some latency to the signal. So you want to be careful when you use it on really time-sensitive stuff like drums, etc. Now that we have that background, I'm going to talk about using the BV512 in equalizer mode. So you can use the BV512 as an equalizer, just like a standard EQ. But I don't recommend using it like that. It's much more interesting and useful to use it to do some sound design instead. So I'm going to demonstrate some of that for you, and we're going to start out by playing a drum loop. So now I'm going to switch on the BV512 here. And you can instantly hear a change in the sound. And that's interesting because none of the settings are changed from neutral. So you'd think that if you didn't change the EQ band at all, your sound wouldn't change, but actually it does. And it differs depending on how many bands that you use. So you can hear there, even at neutral, in 16 band mode, there's a really large effect to the transients of the drum loop. And then even more in 32 band. In FFT mode, there is no difference when all the settings are bypassed. That's due to the math behind it, and that's why it introduces some latency to the signal. When I work with the BV512 in EQ mode, I like to usually use 4, 8, 16 bands because you can sculpt the sound nicely, but it doesn't mess around with your transients too much. 512 mode, like I said, you have to be careful with it in regards to latency, so I tend not to use that as much. Alright, so now I'm going to just draw a kind of a random curve into these EQ bands. Well, bandpass filter bands actually. So that's very different. That's introduced some resonances to the signal. So now the interesting thing that we can do is shift those resonances in the frequency spectrum. So we can shift them lower or higher, essentially imposing that EQ shape up and down the frequency spectrum. So I've got a couple other loops here that might be interesting to hear that sound on. Here's a tabla. And here's some synth chords. So as you might imagine, it's really cool to modulate that shift knob. And I do that a lot in a lot of my presets. Okay, so we're going to use the Dr. Rex LFO to modulate shift. So in this case, it's a 4-bar triangular modulation. But you could use a variety of shapes. Okay, so now moving on, I've got some different shapes, EQ shapes done up in the next vocoders, and I'm going to show you those. So one of my favorite techniques is to actually draw in, this would basically be like a double notch filter. And that's one of my favorite filters in the Native Instruments Massive synth. And it's pretty hard to pull off something similar to that using Thor, but you can get something fairly close using this BV512 set up with a shape like this. You've got 2 notches and a peak in the middle. So let's hear that. And let's modulate that shift with this matrix. Of course, we can control the amount of modulation with this knob here. So that's something a little bit more subtle. It's definitely a more subtle effect on the tabla for sure. Easier to hear on those chords. Okay, so now I've got the FFT mode set up with another curve I just drew in. And you'll find that the FFT mode sounds the most resonant and maybe exotic is the word. We could hook up the matrix to this BV512. And here you can notice that really pronounced kind of smeared transients when you use the 16 or 32 band mode. So the great thing about this technique is that it can give you some morphing and moving sounds without falling back on, the low pass filter with resonance or whatever. There's freedom here to create a whole variety of different filtered type sounds. And it's easy to experiment with. And it really doesn't add very much CPU because the BV512 is quite optimized at this point. One technique that works really well in concert with the BV512 EQ is the equal power crossfade we discussed last month. Often what I like to do is mix in the dry signal with one of these really resonant and shifted processed BV512 signals. So definitely give that a shot and see if you can find a nice balance between the dry and EQ'd signals. Now I'm going to talk about triggering the EQ bands using CV signals. So once again, I've got these factory library chords set up in the Dr. Rex. And what we want to do is run that through the BV512 and actually trigger different bands at different times. And what we're going to use to do the triggering is a drum beat set up in Redrum. Redrum is great for this because you can output a gate CV signal from every separate channel. So let's just play this Redrum beat first. Pretty basic house stuff. Okay, now I'm going to switch the BV512 on and you'll hear how the different EQ bands are being triggered. So if we flip it around, what you can see is that the second band, the fourth, fifth, and sixth bands are being triggered by CV signals. So you can use that in a variety of ways. I could have hooked up an LFO onto a band and, had it fade back and forth. In this case, we're just using the gate pulses so that we can get some rhythmic action going. Let's just mute the reed drum so we can just hear its effect on the chords. So if you try this yourself, running the reed drum CVs directly into the band levels, you're going to run into a bit of a problem. Because the gate pulses are so fast that they don't really give enough sustain to keep the band levels where you need them to be audible. So we have to do a little workaround for that, and I'll show you how it works. So you can see here, I'm running the gate out from the kick drum on the reed drum to our first CV input on a Thor. This Thor is strictly for CV processing in this patch. So let's open it up. It's pretty simple. Basically what we've got is this CV coming in, triggering the global envelope gate, and then we send that global envelope out, CV out 1. And that goes directly into the band level. This way we can control exactly what kind of pulse we want to trigger that band level using the envelope controls. So there's kind of a long sustained bass note from that kick, or just really punchy. So we've got 3 Thors here because we're actually using 3 different CV signals. The first one is for the kick, the second one is for the open hi-hat, and the third is for the clap. So in a way, you're actually doing vocoding here, because if we just run the raw signal into the BV512 in vocoder mode, we'd be modulating the bands of the vocoder based on our drum loop. But in this case, we can choose which reed drum channel triggers which band level. So you could have the bass drum triggering actually high frequencies. Let's just switch this up for a minute. So you can kind of wire it in reverse, or you can wire it any way you want. So you can kind of create your own custom vocoder using the BV512 EQ mode and the gate level, the band level CV inputs. Now we're going to talk about some different and non-standard ways that you can use the BV512 as a vocoder. So besides the usual vocal and drum applications for a vocoder, you can also combine 2 synthetic patches together and get some really interesting sounds. So we're going to start out with a really basic saw patch. I'll play a note for you here. It's just an octave saw from Thor. Okay, so that's going to be our carrier. And our modulator is going to be some string samples from the NNXT. Okay, so you can see how this is wired together on the back. We've got our Thor going into the carrier, our NNXT going into a Spider audio, just so that you can hear the dry sound easily, and then into the modulator input. So let's hear how that sounds. So that's in the FFT 512 mode. So that imparts the most characteristics from the modulator onto the carrier. It sounds most clean and realistic. As we go down, it's progressively more noise-based almost and synthetic. So I'll just play a chord here. So you can hear all that noise in 4-band mode. That can be useful sometimes. And of course, remember the FFT mode has that latency, which honestly wouldn't bother me with a pad string patch like this. Of course, you can use the shift knob as well. So you can get some hybrid patches that mix two synthetic sounds together, or sampled sounds, of course. And some really interesting results are possible. I'm going to load up a different sample here. It's called the Bell Pad. So let's hear that first dry. So it's amazing that even though we're actually hearing no audio whatsoever from the Bell Pad, that it's imparting so much of its tone just onto the saw signal. And then as we move out of FFT to the 32 bands and below, it's progressively less realistic in terms of the bell sound. Before I leave this idea, I want to show you one thing that's missing from a patch like this. The bell pad and the strings I showed you are actually a stereo patch, but we're using them as a monophonic modulator. And next I'm going to show you how to get a stereo modulator to modulate a stereo carrier. Now we're moving on, and I'm going to show you how to do a stereo vocode. So I've got essentially the same patch as chapter 3 pulled up here, and I'm going to flip it around, and we're going to consider how to get this going in stereo. Okay, so obviously there's only one modulation input per BV512, so we need to add another BV512. All right, so now we're going to split the modulator going into both BV512s, split on a stereo basis. And we're going to do the same thing with our Thor input. So now we've got them split up. Essentially, we've got one BV512 with a mono carrier, mono modulator, and down below, once again, a mono carrier, mono modulator, just with each side of the stereo signal. So now we're going to output just the left side of the signal. And we're going to take those two mixer channels and hard pan them. Okay, we've got a little bit of a discontinuity there because obviously we're going to need very similar or the same settings on both vocoders, or else it's going to sound strange between the left and right channel. And let's go back to our strings patch as well. So there's a whole lot more stereo movement in there now. So this is a really useful technique if you're vocoding together any stereo sources. And since vocoders tend to be used with voice as the modulator, that's why it's only a monophonic input. But if we're going to use it like this, vocoding together two synthetic or sampled sources, then a lot of the times your sources are going to be stereo. So this is a great technique to use in that case. We've looked at ways that you can use the vocoder to impose the frequency spectrum of one sound onto another. So following from that, we can actually create a crude pitch shifter using the vocoder. This technique is called a phase vocoder, and I'll tell you how it works first. Basically, we're going to use broadband noise as the carrier waveform, and we're going to use whatever sound we'd like pitch shifted as the modulator. So we're going to start out with a drum loop. And now that's the sound of a phase vocoded drum loop. So what we're hearing is the noise run through the BV512 in FFT mode. So each band is being modulated by the bands of the drum loop. So we're hearing an approximation of the drum loop using 512 bands of noise, essentially. This phase vocoder patch, I should mention, I originally created for the Record plus Reason sound bank. It's a free bank of effects patches that Propellerhead released along with Record. So it's fully mapped, so I can show you a couple of the functions of it. We can switch the bands here. So once again, it's progressively more noisy as you head down from 512 all the way down to 4. But the real trick here is that we can use the shift knob to pitch shift the drum loop. Let's go back to 512. Also, by using the decay knobs on the BV512, we can increase the decay on each frequency band, and that kind of ends up sounding like some artificial reverb, or it can make the drum hits very quick. So listen to this. So you can create some kind of cinematic ambient drum hits pretty easily with this technique. Of course, we can crossfade between the dry and wet signal. So let's go back to what the dry sounds like. So it's far from being an exact recreation. It's an approximation of the same sound using vocoded noise. Just to give you a better demonstration of that, I'm going to let you hear what these Thors are actually producing for the carrier waveform. So we'll just bypass these vocoders and push play. And it's pretty noisy, so I'll turn it down a bit. So yeah, that's the carrier waveform, just stereo noise. So now let's hear how a couple of other sounds react through the phase vocoder. Let's try that tabla loop. Notice how the stereo spread of the original loop is preserved. That's because we're using this stereo vocoding technique from the last chapter, of course. Okay, now we're going to play those synth chords. Okay, now we're running into the limitation with this technique. It doesn't work well for chords, polyphonic, complex polyphonic material. It's just a mess. So you can't really pitch shift something like that using this technique. It just doesn't work well. All right, let's continue on. And I've got a little guitar loop here. Hear it dry first. Well, harp or guitar, I'm not sure. Now it works better because it's more monophonic, one note at a time. That's actually pitch shiftable, even if the quality is pretty iffy. It can be an interesting sound design technique. Now, moving below the FFT, it's not really intelligible. So for anything melodic, you definitely need to be using the FFT setting. So to summarize on this technique, I really like the phase vocoder for mangling percussion, drum sounds, loops, anything that's somewhat inharmonic. Like when we pitch shift a drum loop, we don't necessarily care if we're going to, G, G sharp, or A with it. It's just higher or lower. So it works really well with that kind of material, and it works really well to create ambient, reverberant, cinematic style percussion. I've added a couple of other controls on there that you're welcome to explore. And that's going to do it for our look at the BV512. Alright, that's the end of the December 2009 issue of Reason Wizardry. Thanks so much for watching, have a great holiday, and best wishes in 2010 from us at Nucleus Sound Lab. Cheers.